population density is the number of people per unit of area. This may be calculated for a county, a city, a country, another territory, or the world. To find the population density, all you have to do is divide the population by the area. And that formula will not be provided for you. But what I can recommend as we go through our two examples that we're going to do momentarily is that I write down that formula every time so that by the time you get to the test, you will know what the formula is. So the first one, what is the population density of China? If the area of China is 5,795,162 square miles, and the population is 1,321,851,888 people, round your answer to the nearest whole number. Well, once again, what the formula is its total population divided by the area. And that's actually how I write it. I abbreviate it, but it's total population divided by area. So we can take our population, and it's 1,321,851,888 divided by the area of China, which is 5,795,162. And Desmos or the calculator, whichever works for you, is what we need to type in. So the hardest part is if you even write down those numbers. But be careful that you type it in correctly, which is what I'll have to be careful with as well. 1,321,851,888 divided by 5,795,162. And here we get our answer. And typically, what we're going to say is, we're talking about people here. There's 228.0957613 people per square area. We oftentimes round the people to the nearest whole number, which is 228 people per square mile. Again, conceivably, the hardest part is either copying down the numbers correctly or typing them into Desmos or your calculator correctly. Again, it's going to be the total population divided by the area. So do something so that you don't have to memorize it. Come up with some technique. Total population divided by area. And this time we're looking for the population density of Canada. And our area is 3,854,085 square miles, and our population is 33,056,500. And we type it into our calculator. We type it into decimals. It's the total population divided by the area. And once again, we're talking about people. So when we look at this, I know that it's roughly 8.6 people per square mile. And then this one says round to the nearest whole number. So let's go to 9 people per square mile. One other kind of density that we're going to work with is just the regular density where you're looking at the amount of mass per unit of volume. So any solid object that's less dense than water floats, just a little bit of trivia there. But the formula on this is P equals M divided by V. And it's a goofy way to remember things, but I'm not sure why P is used for density. So what I came up with in my head, at least, I don't write it, but I think of DMV, which reminds me of Department of Motor Vehicles, and that's how I remember the formula. So it's a wacky way. Again, what works for me doesn't necessarily work for you, but if it works for some of you who have really wacky ways of remembering things, so D for density instead of P, but then motor vehicles is how I remember that formula. And again, I just write it down every single time when we get to the density, actually calculating the density. So finding the density of a cube of sugar weighing 11.2 grams, measuring 2 centimeters on the side. And you don't even really need to draw the picture, but here, remember, is a cube. Something that looks like that. And all it says find the density of a cube of sugar weighing that, and 2 centimeters on the side. And again, I don't even know why I necessarily drew the picture, except that we need to find the volume of the cube. Because once again, the formula is P equals M divided by V. And we know the mass. The mass is the 11.2. But we don't know the volume just yet. So we come over here and you don't have your reference papers in front of you. But to find that, the area of the base is going to be 2 times 2. That's the area of the base. And then our height of the cube is also 2. So our volume is going to be 8 cubic centimeters. And once we know the volume, then we can go back and fill in our formula, which is now 11.2 divided by 8. We can type it in here to Desmos or into our calculator. 11.2 divided by 8 gives us 1.4. And then our units. 1.4 grams per centimeters cubed. And to finish, one little piece of information that we might need to work with a little bit more, but it says Jeremy wants to know the density of a rock in grams per cubic centimeter. The rock has a mass of 1.08 kilograms and a volume of 400 cubic centimeters. What is the density of the rock in grams? So right now what we're given is we're given kilograms. Eventually what we need to get to is we still need to use this formula here. But when we start, we need to convert to kilograms. And the way that I like to work with it is I'm going to take 1.08 kilograms. And what I know is that 1 kilogram is 1,000 grams. So ultimately what happens is we need to multiply the kilograms by the grams here. The kilograms cancel out. And worst comes to worst, if you have to type it into your calculator or type it into Desmos, the 1.08 times 1,000 gives us 1,080 grams. And now that we've got that in terms of grams, we have everything that we need, because it says, again, the rock has a mass, so that's going to be our mass, and a volume of 400 cubic centimeters. And we can fill those values back into our formula to get our density. So the density equals 1,080 divided by 400, and we type that in. 1,080 divided by 400, and we end up with 2.7, and then we'll put our units in, because we do want to have grams per centimeter, but 2.7, and now it's grams per cubic centimeter.